Hello, in this lecture we will find the radius of the red circle. In the drawing we have a red circle and the center of the red circle is at point O, and inside the circle we have a rectangle. The size of this line segment is 3 units and the size of this line segment is 6 units, and we want to find out the radius of this red circle. First of all, we will define this point as point M. So actually line segment MC, the size of line segment MC is 6 units, and then we will define this point as point N. So the size of line segment AN is 3 units, and then we will define the line segment OM as Y. Again, line segment OM equals to Y, and we will define line segment ON as X. That is to say, ON equals to X. Okay, OM equals to Y, OM equals to Y, and ON equals to X. ON equals to X. And actually line segment OC is the radius of the red circle. OC equals to R. Okay, line segment OC is the radius of the red circle because of the fact that line segment OC starts from point O, that is the center of this circle, and ends at point C, that is a point on the circle itself. For that reason, line segment OC is defined as the radius of this circle, and also line segment AO or OA is also the radius of this circle. OA equals to the radius of this circle. Okay, OA equals to the radius of this circle because of the fact that line segment OA starts from point O, that is the center of the circle, and ends at point A, that is a point of the circle itself. For that reason, line segment OA is the radius of this circle. So actually both those two line segments OC and OA are the radiuses of this circle. So for it we can deduce that OC equals to OA because both of them are radiuses of this circle. So we write our first equation that states that OC equals to OA because both of them are radiuses of this circle. Okay. But we know that OC equals to y plus 6. So we can substitute OC in the first equation by y plus 6. And OA equals to x plus 3, so we can substitute OA by x plus 3. Okay, OA equals to x plus 3, so we can substitute OA in the first equation by x plus 3. Okay, so we got the first equation that states that y plus 6 equals to x plus 3. Now we will subtract 6 from this first equation. So we subtracted 6 from this first equation. We got that y plus 6 minus 6 is y, and x plus 3 minus 6 equals to x minus 3. So we got from the first equation that y equals to x minus 3. But as I've already told you, MB and O is a rectangle, and in any rectangle the parallel sides are equal to each other. So if MO equals to y, then the parallel side NB will be also equals to y. Okay, so NB also equals to y. But we know that y equals to x minus 3, so we can write here that y equals to x minus 3. Okay. Actually, line segment OB is also the radius of this circle because of the fact that line segment OB starts from the center of this circle, that is to say from point O, and ends at point V, that is a point on the circle itself. For that reason, line segment OB is the radius of this circle. Okay, so we can write here that OB is the radius of this circle. Okay, OB is the radius of the circle. OB equals to R. But OA is also the radius of this circle, and OA equals to x plus 3. So both OB and OA are radiuses of the same circle, and OA equals to x plus 3. So OB, that is also the radius of this circle, will be also equal to x plus 3. So we can write here that OB is the radius of this circle, so it is also equals to x plus 3. Okay. So actually all the angles in a rectangle equals to 90 degrees. So and especially in the rectangle OMBN, all of its angles equals to 90 degrees, and especially angle ONB equals to 90 degrees. Okay, for that reason, triangle BON is a right triangle because angle ONB equals to 90 degrees. Okay, so we actually can find out the value of x in the right triangle OBN. Right, in the right triangle, the right green triangle OBN, we can find the value of x. Okay, according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So we can write our second equation that in the right triangle OBN, the square of the hypotenuse, that is to say x plus 3 square, equals to the sum of the square of the perpendiculars, equals to x squared plus y, but y equals to x minus 3, so it is x minus 3 squared. Okay, so in the right triangle OBN, the square of the hypotenuse is x plus 3 squared, equals to the sum of the squares of the perpendiculars, equals to x squared plus x minus 3 squared, plus x minus 3 squared. Okay, so in this second equation we will open the brackets. We'll get that x plus 3 squared equals to x squared plus 9 plus 6x equals to x squared plus x squared plus 9 minus 6x So we opened the brackets in this second equation. X plus 3 squared equals to x squared plus 9 plus 6x, according to the formula that a plus b squared equals to a squared plus b squared plus 2 times ab, when a equals to x and b equals to 3. Okay, and at the other side of the equation we have x squared and x minus 3 squared equals to x squared plus 9 minus 6x, according to the formula that a minus b squared equals to a squared plus b squared minus 2 times ab when a equals to x and b equals to 3. Okay, so in this second equation we have x squared in this side of the equation and we have x squared in the other side of the equation, so x squared is cancelled and we have 9 in this side of the equation and 9 in this side of the equation, so 9 is also cancelled and we actually left with this side of the equation we left only with 6x and in this side of the equation what is left is x squared minus 6x. Okay, so we got that 6x equals to x squared minus 6x. We will subtract 6x from this second equation. So we subtracted 6x from this second equation. So 6x minus 6x is equals to 0 and x squared minus 6x minus 6x equals to x squared minus 12x, because minus 6x minus 6x equals to minus 12x. The next step, we will take a common factor x from out of equation number 2. Again, we will take a common factor x out of equation number 2. We get that so we took a common factor x from this equation. We got that 0 equals to x times x minus 12, and actually we have two solutions to this equation. The first solution, x equals to 0, is incorrect because x is the size of the side of the rectangle and it can never be 0, it must be a positive number, so x equals to 0 is incorrect. And the other solution is that x minus 12 equals to 0. Okay, so I'll write it down. So if x minus 12 equals to 0, then x equals to 12 units. So we got that x equals to 12 units. X equals to 12 units, but we know that the radius of this circle equals to x plus 3. The radius of this circle equals to x plus 3. So the radius of the circle equals to x plus 3, and x equals to 12 units. So 12 plus 3 units is 15 units. So the radius of the circle is 15 units. Okay. The radius of the red circle is 15 units. Okay. This radius equals to 15 units. That is the answer to the question. Now I will summarize the lecture. Actually, we wanted to find out the radius of this red circle. We know that the center of this circle is at point O, and inside this red circle we have a rectangle. The size of line segment MC is 6 units, and the size of line segment AN is 3 units. We defined line segment ON as X and line segment OM as Y. So we actually know that line segment OC is the radius of this circle because of the fact that it starts from point O, that is the center of this circle, and ends at point C, that is a point on the circle itself. For that reason, line segment OC is the radius of this circle, and also line segment OA or AO is also the radius of this circle because it starts from point O, that is the center of this circle, and ends at point A, that is a point on the circle itself. For that reason, line segment AO is the radius of this circle. So both those line segment OA and OC are the radiuses of this circle. For that reason, we can write our first equation that states that line segment OC equals to line segment OA because both of those line segments are the radiuses of this red circle. But we know that OC equals to y plus 6. So we can substitute OC in the first equation by y plus 6. And also OA equals to x plus 3. So we can substitute OA in the first equation by x plus 3. So we got that y plus 6 equals to x plus 3. We substituted 6 from this first equation and we got that y equals to x minus 3. Okay, so in this rectangle the parallel sides are equal to each other. So if OM equals to y, then OBM, that is parallel to OM, also will be equal to y. But we know that y equals to x minus 3, so we can add here that y equals to x minus 3. And also line segment OB is the radius of this circle because of the fact that it starts from point O, that is the center of this circle, and ends at point B, that is a point on the circle itself. For that reason, line segment OB is the radius of this circle. But OA is also the radius of this circle, and it equals to x plus 3. So OB, that is the radius of this circle, will be also equal to x plus 3 because both of them are radiuses of this circle. Okay, now we will focus on the right triangle BON. Actually, the right green triangle OBN is a right triangle because of the fact that all the angles inside the rectangle equals to 90 degrees, especially angle ONB equals to 90 degrees. For that reason, OBN is right triangle. So in this right triangle we can use the Pythagorean theorem in order to find out the value of x. The Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, x plus 3 square equals to x square plus x minus 3 square. Okay, so actually we have one equation with only one variable x. So we found out from this second equation that x plus 3 square equals to x square plus x minus 3 square, that x equals to 12 units. Okay, but we know that the radius itself equals to x plus 3, so the radius will be equals to x plus 3, that is to say to 12 units, plus 3, that is to say the radius of this circle will be equal to 15 units. This is 12 units plus 3 units equals to 15 units. The radius of this circle equals to 15 units. Okay? Thank you very much.